In this session, we will learn how to calculate the last digit of multiplications. Now, how to calculate the last digit of addition or multiplication of two or more than two numbers. Let's take a look at a simple example. What is the last digit of the product 12 into 37? So in this case, we do not need to multiply 12 into 37, as most of you would already know. So what we need to do is we take the unit digit of 12, which is 2, and then we take the unit digit of 37, which is 7, and we multiply 2 into 7, which gives you 14. The unit digit of 14 is actually also the unit digit of the multiplication 12 into 37. The same method can be followed if the number of numbers multiplied is more than 2. Let us see that. What is the last digit of the product 12 into 37 into 73 into 48? Again, what is the unit digit of 12? The unit digit of 12 is 2. Then the unit digit of 37 is 7. The unit digit of 73 is 3. And the unit digit of 48 is 8. We multiply these four numbers. 2 into 7 gives you 14. So 14 into 3 gives you 42. And 42, you eliminate the 4 and retain the unit digit 2. 2 into 8 gives you a 16. And the unit digit of 16 is also the unit digit of the product 12 into 37 into 73 into 48. So our required unit digit is 6. Now these two were very simple examples. But suppose I ask you how to calculate the unit digit of the number 123 raised to the power of 47. It will be very difficult for any one of us to multiply 3 into 3 into 3 47 times. Theoretically speaking, it can be done. But given the time constraint in most of the competitive exams, to solve it in a time constraint, we need to adopt a different approach. Let us see what approach. This approach is the pattern method of calculating the unit digit of a number of the form a raised to the power of n, where a can be any natural number and n is the natural power of a. For example, 2 to the power 47. How do you calculate the unit digit of the expansion of 2 to the power 47? So let us start. 2 to the power 1 gives me a unit digit of 2. 2 square gives me a unit digit of 4. 2 cube gives me a unit digit of 8. 2 to the power 4 gives me a unit digit of 6. 2 to the power 4 is 16. The unit digit is 6. 2 to the power 5 gives me a unit digit of 2. 2 to the power 6 gives me a unit digit of 4. 2 to the power 7 gives me a unit digit of 8. And 2 to the power 8 again gives me a unit digit of 6. So we can see here that when 2 is raised to powers 1, 2, 3, 4, 5, 6, 7, 8, the unit digits repeat in a pattern of 2, then 4, then 8, then 6, again 2, 4, 8 and 6. So we can utilize this pattern to calculate the unit digit of our number 2 to the power 47. So how can we do that? We can see here that any number that is of the form 2 to the power of a multiple of 4, which I represent as 2 to the power 4k. So 2 to the power 4, 2 to the power 8, 2 to the power 12, all of them will have unit digits of 6. This is one observation which you can make here. Similarly, any number which is of the form 2 to the power 4k plus 1. 4k plus 1 is nothing but the power when divided by 4 yields a remainder of 1. Has a unit digit of 2, we can see here. 2 to the power 1 and 2 to the power 5. Both of them can be represented as 2 to the power 4k plus 1. The unit digit is 2. Similarly, the unit digit of any number of the form 2 to the power 4k plus 2. Again, 2 square and 2 to the power 6 represent this category. The unit digit is 4. Similarly, unit digit of any number which is of the form 2 to the power 4k plus 3. So 2 to the power 4k plus 3 again represents a multiple of 4 plus 3. A multiple of 4 leaving a remainder of 3. So 2 to the power 3 and 2 to the power 7 represents this category, and the unit digit is 8. So when we look at our number 2 to the power 47, the first thing that we need to do is divide the power 47 by 4 and check the remainder. In this case, when 47 is divided by 4, the remainder is 3. So therefore, 2 to the power 47 can be represented in the form 2 to the power 4k plus 3. So if 2 to the power 47 is equivalent to 2 to the power 4k plus 3, what is the unit digit? The unit digit is 8. So can we divide by 4 for all numbers? Say we've just done this for 2. Can we do the same, or can we apply the same method for the numbers 3, 4, 5, 6, 7, 8 and 9? Yeah, the method applicable is the same, but the patterns for different numbers might be different. So I'll list down all the patterns for different numbers. So for different digits, as I said, the patterns may repeat after different numbers. And let us see what these patterns are. The pattern for the number 2, 3, 7 and 8, the pattern of unit digits. It repeats after 4 terms for any number which ends in 2, 3, 7 or 8. For any numbers that ends in 4 or 9, that means for any number whose unit digit is 4 or 9, the pattern would repeat after 2 terms. Similarly, for any number whose unit digits are 0, 1, 5 and 6, the pattern will repeat after 0 terms. That means these numbers when raised to any power will always result in the same unit digit. For example, any number which has a unit digit of 1, if you raise it to any power, the unit digit will always remain 1. Let us solve a few questions based on our method, our pattern method. Find the unit digit of 3 to the power 87. The first thing is, we should remember that the pattern of 3 repeats after every 4 terms. So number of terms or powers of 3 after which the pattern of unit digit repeats is equal to 4. So we have to divide the power 87 by 4, which yields a remainder of 3. Which means 3 to the power 87 can be written as 3 to the power 4k plus 3, and therefore the required unit digit is the unit digit of 3 to the power 3, which is equal to 7. 3 cube is equal to 27, and the unit digit of 27 is 7, which is also the unit digit of the expansion of 3 to the power 87. Find the unit digit of 127 raised to the power of 127. In this case, the unit digit will depend on the unit digit of 7 to the power of 127. Again, if you check from our list, the unit digits for 7 repeats after every 4 powers. So again, divide 127 by 4 and the remainder is once again 3. If the remainder is 3, that means 127 can be written as 4k plus 3, which means the required unit digit is equal to the unit digit of 7 cube, and 7 cube, which is equal to 343, the unit digit is 3, and therefore the unit digit of 127 raised to the power of 127 is also 3. Find the unit digit of 124 raised to the power of 127. In this case, the unit digit depends on the unit digit of 124, which is 4. And you will observe that pattern of 4 repeats after every 2 digits. So if the pattern repeats after every 2 digits, we'll divide the power 127 by 2. 127 when divided by 2 yields a remainder of 1. So the required unit digit is the unit digit of 4 raised to the power of 1, and therefore the answer is 1. So 124 raised to the power of 127 will give us a unit digit of 4. So with this, we come to an end of this session. In case you have any feedback or any query, please feel free to write to us at studentservices@pfindia.com. Thank you.